Hello guys, welcome back. This is problem set 8 of the lecture series Signals and Systems. In this video, we'll be solving some questions on discrete time Fourier series. So, let's get started. Coming to the first question, a discrete time periodic signal x of n is real valued and has a fundamental period n equal to 5. So, n is equal to 5. The non-zero Fourier series coefficient for x of n are, so they have given the non-zero Fourier series coefficient, and as you would expect for real signals, what do we have? We have ak equal to a minus k star. So that they have also given it correctly. So we need to express x of n in the form x of n equal to a naught plus summation k equal to 1 to infinity ak sine omega kn plus phi k. So this is also another form of representing x of n in terms of sinusoidal signals. So this can be derived easily from the complex exponential expression. So if we have k equal to minus infinity to infinity, we have ak e power jk 2 pi by n into n, right? And we know for real signals, your ak equal to a minus k star, or in other words, your a minus k equal to ak conjugate, right? So let me assume that my ak is equal to ak e power j phi k. Okay, this is magnitude and this is the phase of ak, assuming that ak is a complex number. So what will be my a minus k? So ak is real and ak and phi k are real. So minus j phi k. So this is what I'll get. So now if I substitute these in this expression, so I'll get x of n equal to, let me take a0 out, okay? Then I'll have summation k equal to k equal to 1 to infinity a minus k e power minus jk into 2 pi over n into n plus ak e power jk 2 pi over n into n. So I'm gathering all the positive case and negative case and writing it together as a summation of 1 to infinity. And since it is real, your a0 should be equal to a minus 0 star, which means it is still a0. So a0 should be real. So I'll write a0 as this constant. So substituting, what will I get? a0 plus summation k equal to 1 to infinity a minus k is ak e power minus j phi k e power minus jk into 2 pi over n into n plus ak e power j phi k e power jk by into 2 pi by n into n, right? So if I take ak as common out, I'll be remaining with e power j into k into 2 pi by n into n plus phi k and plus e power minus j into k into 2 pi by n into n plus phi k. So it is nothing but a naught plus summation k equal to 1 to infinity ak 2 cos k into 2 pi over n into n plus phi k. Correct? So this 2 I can write here, 2 times ak. So this is in cos form. If you want to convert into sine form, I can use sine pi by 2 plus theta equal to cos, right? So I can use it and write. And this just constant terms, so I can also replace this with ak. Okay? So this is how you get this expression. And let us see how to do it for this case. So we have this coefficients. So this is e power j pi by 4. Okay. So my x of n, my n is equal to 5. So I can write k equal to 0 to n minus 1. So 4 ak e power j k into 2 pi over 5 into n. So what I'll get? I'll get 1 into 1 plus my 1 term is 0. So I'll get 2, a2, which is nothing but e power j pi by 4 into e power j 2 into 2 pi by 5 into n. And I will also have minus 2, right? So which is nothing but e power minus j pi by 4 e power j 2 into minus j 2 into 2 pi by 5 into n. And I have 4. So 4 it is 2 e power j pi by 3 e power j 4 into 2 pi by 5 into n plus 2 e power minus j pi by 3 e power minus j 4 into 2 pi by 5 into n. So what will this give me? It will be 1 plus this and this I can combine. So what will I get? I will get 2 into cos of 4 pi by 5 n plus pi by 4 plus these also I can combine. I will get 4 into cos of 8 pi by 5 n plus pi by 3. Now I need it in this form, sin omega kn plus phi k. So what I will do? I will just use 1 plus 2 sin pi by 2 plus theta. So I will get 4 pi by 5 n. Pi by 2 plus pi by 4 will give me. So 2 times, so 3 pi by 4. So plus 3 pi by 4 plus 4 cos 8 pi by 5 n plus pi by 3 plus pi by 2 will give me 5 pi by 6. 5 pi by 6. This is sin. So this is the expression they have asked and we have written it in that form. Okay. Okay, moving on to the next question. Let x of n be a real and odd periodic signal with period n equal to 7 and Fourier coefficients ak. Given that a15 equal to j, a16 equal to 2j and a17 equal to 3j. Determine the values of a0, a minus 1, a minus 2 and a minus 3. So they have given x of n as real and odd. So for real what you have x of n equal to x star of n. And for odd you have x of n equal to x of minus n. So this implies that your ak equal to a minus k conjugate, and this implies that your ak is equal to this minus a minus k. So both together imply that your ak is equal to, so this will be minus ak, so minus ak conjugate. So this says that your AKs are odd and this says that your AKs are purely imaginary. And we know that your AK is equal to AK plus n, correct? Plus some mn, where n is the period. So your n is equal to 7. And you have a15. a15 is equal to a15 minus 7, which is nothing but a8 equal to a8 minus 7, which is nothing but a1 equal to j. And similarly, your a16 will be equal to a2 equal to j. And your a17 is equal to a3 equal to j. And since it is odd, ak equal to minus ak, minus a minus k, your a0 is equal to minus a0, which implies that 2a0 equal to 0, which implies that your a0 is equal to 0. So a0 we have found, a minus 1, minus 2, minus 3. So a1, 2, 3 we have found. So a minus 1 is nothing but minus a1 because it is odd. So it is minus j. And a minus 2 is again, this is 2j and 3j, right? A minus 2 will be minus a2 minus 2j and a minus 3 is equal to minus a3, which is nothing but minus 3j. Okay, so that is what they have asked us. So this is the solution. So let us move on to the next question. Suppose we are given the following information about the signal x of n. So x of n is a real and even signal. X of n has period n equal to 10 and Fourier coefficient ak, and a11 equal to 5, and 1 by 10 summation n equal to 0 to 9, x of n whole square equal to 50. Show that x of n equal to a cos bn plus c and specify numerical values for the constant a, b and c. So we need to find x of n first. So let us use the given information. So x of n is real. So this we already saw. This implies that your ak equal to a minus k conjugate, and x of n is even. This implies that your ak is equal to a minus k. This together implies that your ak equal to a k conjugate, which implies that ak's are real, and this implies that your ak's are even. Okay, so that is the one information. So second, your period is equal to 10 here, correct? And a11 is given as 5. So a11 is 5, then a11 minus 10 equal to a1 is also equal to 5 because of the periodicity of ak's, correct? If a1 is equal to 5, I know my a minus 1 is equal to a1 is equal to 5. So this is valid. So fourth one, what is given? 1 by 10 summation n equal to 0 to 9 mod x of n whole square equal to 50. So by Parseval's theorem, your 1 by n summation n equal to 0 to n minus 1 mod x of n whole square is equal to summation k equal to 0 to n minus 1 mod ak square, correct? So if you just add a1 square plus a minus 1 square, it is going to equal to 25 plus 25 equal to 50. So this only is covering all this, right? So your all other ak's should be equal to 0 for k not equal to minus 1 comma 1, which implies that your ak equal to 5 for k equal to minus 1 comma 1 and 0 otherwise. Okay, but we have to write x of n in this form. So what will we do? So I'll write x of n equal to, so I can choose any period, right? Summation k equal over n ak e power jk 2 pi by n into n. I can choose any period. It's not necessary that I should choose from 0 to n minus 1. So I'll choose a period such that your minus 1 and 1 are there. So then what I'll get? I'll get 5 into e power minus j 2 pi by n into n plus 5 into e power j 2 pi by n into n. So this will give me 10 cos 2 pi by n into n. And n is nothing but 10 here. So 2 pi by 10 into n. So I need to find a, b and c. So my a is nothing but 10. My b here is 2 pi by 10, which is equal to pi by 5. And my c is 0. So these are my answers. Okay. So next question, fourth question. When the impulse train x of n equal to summation k equal to minus infinity to infinity delta of n minus 4k is the input to a particular LTI system. Okay, this is the input to a particular LTI system with frequency response h of e power j omega. The output of the system is found to be y of n equal to cos 5 pi by 2n plus pi by 4. Determine the values of h of e power j k pi by 2 for k equal to 0, 1, 2 and 3. Okay, first let me find x of n in the form of sum of complex exponentials. Then I can have a comparisons between y of n and x of n, and then I can find out h of e power j omega. So first to notice is your period fundamental period is n equal to 4 here, because if this is your x of n and this is n, you will have at here 1 and then at 4 1 minus 4 1, and at all multiples of 4 you will have this, right, the impulse train. So now to find out ak, it is nothing but 1 over n summation n equal to 0 to n minus 1 x of n e power minus j k 2 pi over n into n. So this is equal to 1 by 4 summation n equal to 0 to n minus 1. X of n is, I need to consider only over one period, right? Because my n is only in this region. So this is 3. So I'll consider only delta of n e power minus jk 2 pi over n into n. So delta of n into this will give me just 1, correct? So I can take it out of the summation. Only the 0 term, n equal to 0 term will be non-zero, and at that point the value is 1. So all my AKs are equal to 1 by 4. So now I can represent x of n as summation k equal to, or k equal to 0 to 3, 1 by 4 e power j k into 2 pi over n, here is 4 into n. So here also it is 4. Okay. So this is my x of n. So my y of n will be nothing but summation k equal to 0 to 3, 1 by 4 h of e power j k. This is nothing but pi by 2. Pi by 2 e power j k pi by 2 into n. So we have asked to find h of e power jk pi by 2 for k equal to 0, 1, 2, 3. So we can now compare this with what is given. So cos 5 pi by 2n plus pi by 4. This is nothing but e power j 5 pi by 2n into e power j pi by 4 plus e power minus j 5 pi by 2n into e power minus j pi by 4 by 2. So 5 pi by 2 I can write it as minus 2 pi n, because if I add or subtract 2 pi n, it is not going to change my value, correct? Because it is periodic. So what will I get? 4. So I'll get pi by 2 n, correct? Similarly, minus 5 pi by 2n, I'll add 2 pi n. So I'll get minus pi by 2n. So this y of n I can write it as e power j pi by 2n e power j pi by 4 plus e power minus j pi by 2n e power minus j pi by 4. And again, this minus pi by 2n is not in this range, right? So what I'll do, I'll again add 2 pi n. So what will I get here? I'll get 3 pi by 2n. So this is in my range. So minus, I can write it as 3 pi by 2n. So now if I compare this to this, sorry, where is this? This one to this one. For my k equal to 0 term, I don't have any term here. But in x of n, I add a term. So my h of e power j 0 is nothing but 0. And h of e power j pi by 2. So pi by 2 term is here, correct? So what is my h of e power j pi by 2? So your x of n was 1 by 4 and now it has become 1 by 2 e power j pi by 4. So it is going to be 2 into e power j pi by 4. And your h of e power j 2 pi by 2, that is again going to be equal to 0. And then your h of e power j 3 pi by 2 is nothing but again 2 e power minus j pi by 4. So this is your answers. That is what they've asked for. Okay, that's it. So we'll solve just one gate question from EE, because in EC there is no questions based on DFS. Okay. So the only question is, the discrete time Fourier series representation of a signal x of n with period n is written as x of n equal to summation k equal to 0 to n minus 1 a k per j 2 k n pi by n. So they have only given the expression and they are just modified this k and n pi just to confuse you. Okay, a discrete time periodic signal with period n equal to 3 as a non-zero Fourier series coefficients. So we have n equal to 3, a minus 3 equal to 2 and a4 equal to 1. The signal is. So we need to find the signal. So let us first find a0, a1, a2 and okay, only a2 is required. Then I can use x of n equal to summation k equal to 0 to 2 ak e power jk 2 pi over 3 into n. So a0 how I find? So my a minus 3 is equal to a minus 3 plus 3. a0 is equal to 2. And from a4 I can get a4 minus 3 equal to a1 equal to 1. So only these two are my non-zero Fourier series coefficients. So my a2 is going to be equal to 0. So now I can substitute it here. So I have a0 2 plus 1 into e power j 2 pi by 3 into n. But if you see, this is not the expression I need. It is not what is given in the options. So I need to modify this a bit. So if you observe, I have cos 2 pi by 6n. But here I have 2 pi by 3. So what I'll do, I'll take 1 plus 1 plus e power j 2 pi by 3 into n. And I'm going to convert this into cosine 4. So 1 plus, I'll take e power j 2 pi by 6n outside. So what I'll be left with? I'll be left with e power j minus j 2 pi by 6n plus e power j 2 pi by 6n. So now this is of the cosine form, right? So I can write 2 e power j 2 pi by 6n into cos 2 pi by 6n. So this is my answer. So which is nothing but option B. I have 1 plus 2 e power 2 pi by 6n, 2 pi by 6n. Here I have minus, so it is not the answer. Here I have 2 pi by 3, no. And here I have 2 here. So this is also not the correct option. So option B is my correct option. So now let us move on to the second question. Consider a discrete time periodic signal with period n equal to 5. Let the DTFS representation be x of n equal to summation k equal to 0 to 4 ak e power jk 2 pi n by 5, where a0 equal to 1, a1 equal to 3j, a2 equal to 2j, a3 equal to minus 2j, a4 equal to minus 3j. The value of the summation n equal to 0 to 4 x of n sin 4 pi n by 5 is. So here if you see, they have only given the relation for the DTFS. But we know the relation need not be specific, right? It can be over any n. So over any period of 5 here. And we have ak e power jk 2 pi n by 5. And similarly, your summation n equal to 0 to 4 x of n sin 4 pi n by 5. This is what we are required to find. And if you observe your sin 4 pi n by 5 is also periodic. And what is the period? N is equal to 5 here again, right? So the correct period will be 5 by 2. But since 5 by 2 is not a integer, we need to assume that it is 5, right? And it is 5. Okay. So now this is like a product of two numbers, right? Two sequence. Let's say you have x1 of n into x2 of n. You know the discrete time Fourier series is gonna be convolution in the frequency domain. So it will be some k over n, or if you want to find, let's say it is some ck, it is given by summation L over n. And we have, let's say this gives AK and this gives BK. So what will we have? We have AL B into K minus L. So this is what we have. And we can also write ck has nothing but 1 over n summation n over n x1 of n x2 of n e power minus jk into 2 pi over n into n, right? And now you have something of the form of summation n over n 0 to 4 x of n into sine 4 pi n by 5. So to get that, what you have to do, you have to just substitute k equal to 0 here. So your c naught is nothing but 1 over n summation n equal to 0 to 4 x1 of n x2 of n e power minus j k 0 here. So this term will go away and this is what we require. So summation n equal to 0 to 4 x1 of n x2 of n is equal to n into, which is nothing but 5. So 5 into c0, and c0 is nothing but 5 into summation l over n al bk minus l. Okay. So now we already have al here, right? We need to find bl. So what will sine 4 pi n by 5 translate to? So this is nothing but your e power j 2 into 2 pi by 5 into n minus e power minus j 2 into 2 pi by 5 into n divided by 2j. So this says that your, let me call it b. So b2 is 1 over 2j and b minus 2 is minus 1 over 2j, right? And the summation you can take, I will consider from, I can take it over any 5 sequence, right? So I will consider from minus 2 to 2, okay? So C0 is nothing but, C0 is summation L equal to minus 2 to 2. Instead of writing BL AK minus L, again this K we have substituted with 0. So this will be minus L. So instead of writing AL B minus L, it is same as also writing B minus L AL, right? Or the other way. So BL A minus L also you can write. So BL A minus L. Because your convolution is commutative. So anything you can take. So B minus L. So now I know my B minus L is valid only for 2 and minus 2. So if I substitute that, what will I get? I will get A2 B minus 2 plus A minus 2 B2. So A2 I know. A2 what it is? 2j. But then A minus 2 how will I find? I will use the property that your AKs are also periodic with period n. So I will add 5. 5 minus 2 is nothing but A3. What is my A3? Minus 2j. So this is equal to minus 2j. So my C0 is nothing but 2j into minus 1 over 2j plus your A minus 2 is minus 2j into 1 over 2j. So this will give me minus 2. And what is required? I need this summation. So that is 5 into minus 2. So my summation n equal to 0 to 5 x of n sine 4 pi n by 5 is nothing but minus 5 into minus 2, which is equal to minus 10. So which is nothing but option A. So this is the correct answer. So when I check the syllabus for GATE EC, I did not find discrete time Fourier series to be part of it. But as you can see, they have asked this question is in GATE EC 2023. So it is always good to learn these things and not just be sticking to the syllabus. So how much of knowledge you can gain, you have to do it. Yes, of course, they have given you x of n equal to the formula, and it may look straightforward. You just have to substitute your find x of n and then substitute in here and then sum it up. But even then, if you know these kind of analysis and all, it will be very quicker. But also you should be careful that when you are using these and all, you should not make any mistakes like missing out the factor of n, right? Or including an extra factor of n here. So those kind of mistakes you should avoid. So that's all for today, guys. I'll meet you in the next lecture where we'll be discussing about discrete and Fourier transform. So until then, stay tuned, take care, bye-bye.